Good morning, friends. Today, what we will try to solve is a web scrapping from Golang. This is going to be a initial implementation of how do we run so many Go routines to do a web scrapping. Let's start with understanding what are the domains that we are going to hit. I have taken certain domains which we are going to just do a HTTP get and just return the status code from from there as a response. And we are going to use go we are going to spawn multiple go routines in order to get response concurrently from each of these domains. And I've kept a timeout of 10 seconds for now, for us to demonstrate, and then we will fine tune that as we go along. Let's look at the implementation of scrapper. Scrap is the function which takes the inputs to the list of the domains that you have to process, and we are going to define a timeout which helps us to have a definitive time where we need to complete the scrapping part, because we can't go keep on scrapping. First thing is we are going to create a context. This is a parent context, and from the parent context I'm going to create a child context with the timeout. Why I said a child context is context package in Golang is implemented like a tree-based structure. Every time you're going to create a new context, every time you're going to derive a new context from its parent context, it has its benefits. Like if your parent context gets cancelled, all the child contexts which are derived from the parent context will also be cancelled. And the value evaluation, the values that you inject into the context, and the value evaluation also happens from the bottom to the top of the tree, of the context tree. Uh, I recommend you, if you are not aware of it, please go and read the context documentation, or I will take some time in the next videos to explain them. For now, let's take my word and move forward. So what we are going to get is, from the parent context, we are going to create a derived context with a timeout in it. So in this particular case, 10 seconds is the timeout. So I defined a context which is going to expire in 10 seconds. This with timeout function is going to return two variables, a derived context and a cancel function. Why cancel function is useful is, cancel functions allows us to cancel the timeout anytime if we want, before the timeout even expires. That's the idea. But it's always a good practice to cancel it when your program returns, when your program is going to die. In this case, we do a defer cancel, so that in all the cases, be it positive or failure cases in your function, it's going to cancel the timeout. If you want an explicit to cancel, you can cancel it you can call that cancel function anywhere, and all the Go routines which are using the context will get the cancellation message, and if you have a check over there, which we're going to see, will stop its execution and return back, so that we will not have any leakage of coroutines in your program. Now let's look at the problem. So we are going to scrap these websites. In this case, we have around 3, 4, 5, 6, if I'm not wrong, 6 websites that we are going to hit. Instead of looping through them in a sequential manner, I'm going to spawn each HTTP call as a separate Go routine. So I'm going to loop through the domains. I'm going to call, before I come to the wait group, let's take this flow. So there is a loop of domains. I'm going to loop them, and I'm going to call do function as a Go routine. Once, how do I synchronize these Go routines? So before we go and see what is happening within the Go routine, in each Go routine, first let's understand how do we synchronize. So Go routines are compared to threads in other languages like Java and C, C++. The idea is that we need to find a way for this main. If you have understanding of the threading model, so your threads are always bound to your parent, and I think there is a way to join them to the main thread, so that the main thread is blocked until all its child threads are completed their job. It's a similar idea in Golang. The instead of threads, the Golang tend to call these as Go routines, because threads are little costly if you want to spawn a thread, because it has its own stack, it has its own memory management. But Go routines are very lightweight in the nature, be it a memory on the size of the Go routine. So the Go routines are much faster to create and very cheap to create. Having said that, there are ways to synchronize the Go routines to the main thread. In this case, Golang prefers to call everything as a Go routine. So I'll call this as a main Go routine, and we are spawning the number of domains. So in this case, we are spawning 6 Go routines. We need to find a way to synchronize these 6 Go routines back to the main Go routine. That's the idea. There are multiple ways. The recommended way is using the wait group. Wait group is a way of synchronizing multiple Go routines which are spawned from the main Go routine, and the main Go routine will the wait group allows the main Go routine to block until the whole child Go routines have completed their job. How do we do that? Let's look at this. So the template is this. We're going to create a instance of wait group, and we're going to add, it's like a semaphore. I would refer this in similar lines of semaphore or mutex. Mutex is like binary, but semaphore allows you to do more than one. So it's like a semaphore. You add one. So what it tells is there is a wait group. So there is a one Go routine which is you want to wait on. Since we are running in a loop and we are adding one to this particular wait group, so in this case the wait group count will increase to 6, and there will be 6 Go routines that will be spawned. And after this loop is completed, we are waiting. We have said wtg.wait. What the wait group does is it will continuously monitor, well, my count of wait group goes to 0. That is what the blocking call is. So the main Go routine is going to block on line 46 until all the Go routines have completed their job. Now let's look at the functions, the Go routines functions that we are going to write. In this case, I need to pass the wait group to the function, to the Go routine function, and the relevant business parameters to the context. So in this case, domain is the one. So I'm passing domain, and I'm passing channel to get the response if there is any response from the original from the Go routine. In this case, my channel is going to be a status message, a very simple status message. Let's look at how it is done. First, let's look at the status message. So what I'm going to return is a code and the domain. So for which domain, what is the status code for my request? If you want any specific data, we can create it as an interface and then retrieve over the channel. That's possible. Now let's look at the Go routine implementation. So I have passed the context and I passed the domain, the channel, and the wait group. Now the first thing every Go routine should write is a deferred WTG done if they are synchronized using a wait group. This is to ensure that no Go routine, there won't be a deadlock. This is to ensure that no Go routine creates a deadlock, so that no deadlocks are created. What do you mean by this? If you don't call this function, your semaphore on the wait group is still having a +1 where no one is deducting. So it's very important that if you're running a Go routine and synchronizing with a wait sync group, the first statement of your Go routine should be deferred wtg.done. And then we're going to make HTTP calls for this particular use case. So we're creating a URL with a scheme of HTTP, and we're preparing a request, and I'm going to set the request with context. Why this is important is I'm now telling the request that you have to timeout that is defined in the context. So the context which is having since we have got the context we created a context with the particular timeout duration, the context that we pass to the Go routine has the timeout. So and then you call the basic default client.do. So this particular request will timeout as per the context timeout that we have set. If it times out, if there is a successful response before the timeout, then the error will be nil and the response will be http.response. Let's take two cases and evaluate how the behavior would be. Let's take that there is no timeout and we got a proper response from google.com for the moment, which is going to be a set of big XML file or a HTML file followed by the status code. And then I'm going to have two cases. Every time I have to check whether the timeout has happened because of the context. Context has timed out. That means your caller is no more interested in the result of this particular coroutine because its SLA has already been crossed. Now if context is done, I will not put any message onto the channel because I am not interested, because I have already done, so I don't want to write to other channel. So thus ensuring that even if the publisher, even if the main go routine has closed the channel, your go routines are not going to rise to that closed channel, and thus avoiding the panics. So by looking at the context done, I'm simply printing and then breaking and then returning from the go routine. Now this happens in every go routine that we are spawning from the scrap function. In this case, we are spanning 6 coroutines. Let's assume that all 6 coroutines are running concurrently. And from all 6 coroutines, they are going to fire a network call for each of the website that we are going to pass, or which of the domain that we are going to pass. And if they successfully return a response within the context time set, then we will have a message on the channel. If they have timed out, what happens is the response will time out and the context is done, so we will not publish any message onto the channel. Now let's look at how are we synchronizing and how we are retrieving the messages in success case and failure case on the main go routine. Let's look at this example again. So here we waited on this. So now let's say all 6 coroutines are concurrently running and they have returned their responses in a success case. That means there are 6 messages on the channel. So this is the code that actually reads from that channel. You might be wondering why I'm closing channel. Golang channels, you can read from a Golang channel which is already closed, but we cannot publish any message to the channel which is closed. That creates a panic. And this is how I am avoiding publishing a message to a channel which is already closed in the Go routines is by having the context done. That is, I'm checking if the context is done. That means the main Go routine is no more interested in the spawned Go routines responses, and thus ensuring I'm not putting any message onto the channel. So I'm closing the channel and I'm reading the messages. Now let's run this example and see how the behavior is. In this particular case, I have set a timeout of 10 seconds. Now when I run this, so within 10 seconds, I got responses from all the websites that we are scrapping, and many of them have written 200 and Big Basket has written 302. Now let's look at, let's change the timeout from 10 seconds to 1 second and see how many of these websites return a positive response. Now within 1 second, except Google, everyone has timed out, so they require more time to process it. Let's even reduce the time by saying, I'm not sure, let's try this. Except Google, everything has timed out. I think this is not correct. So what I'm going to do is I'm going to set this to millisecond. Wait a minute. Time dot millisecond, I think. Let's see. Give me a moment. Generally, will be an auto population. This is the yes. Now I have kept a timeout of 1 millisecond. That means none of these APIs are going to give me any response. So all of them times out. If I make this to 1000, that's turning to be 1 second. We will see the response that we have already seen, where Google succeeded. Now let's make it to 5000 milliseconds, which is 5 seconds. So that increased the timeout. Now I would expect to see response from everyone. That's it. This is how you fine tune it and use your Go routines to effectively synchronize between your main Go routine and the context timeout is going to be the one which helps you to send a cancellation message to your Go routine so that they don't write to any don't write back to your channels which could be closed. That's all I have from here. One bonus tip before I leave is that you can also explore with deadline from the context package. If you know at what time, if you know a future time where your go routines should not do any operation. That's all I have, and have a great day. If you like the video, please like, subscribe, and share with your friends. Thank you very much.